Out of the black of the western sky, moored in the gently undulating sea of electromagnetic radiation, and otherwise, from an undisclosable location for reasons of security and therefore insecurity, this is Coast to Coast AM. Good evening, everybody. John B. Wells sitting in with you tonight for the second time I've ever sat in with you on Saturday night in my life and yours. And we have a program lined up for you tonight that I think that you will like. For the first hour, James Childs will be with us. He's been on Coast to Coast many times. He writes and lectures on technology and wrote Inviting Disaster, Lessons from the Edge of Technology all the way back to 2001. And much of his writing has dealt with system malfunctions. In other words, he studies things that foul up. And do we ever need him now? So we'll be talking to him very shortly. And then, second, third, and fourth hour, along with some of your calls, if you like, Dr. Lawrence Krauss, who has this idea that science and God cannot coexist. One has little or nothing to do with the other. So we wish a hearty on guard to the doctor and look forward to speaking with him. This should be a lot of fun. A lot of crazy stuff happening in the news. Be sure and check the Coast to Coast website, don't you know, because there are some interesting things on there, as always. Zoologger, unique life form is half plant, half animal. I knew some of those people in school, didn't you? Just kidding. Astronomers weigh in on the Milky Way's true colors. UFO news, the Argentinian OVNI footage is enhanced. And the Phobos Grunt crashes to Earth. That satellite is coming down, I guess, sometime between now and tomorrow night. So we'll just see what happens. This story will tweak some people up a little bit. But let's go ahead and lock and load. This week's revelation by the Centers for Disease Control and Prevention that homicide is no longer the leading cause or among the leading causes of death in the U.S. at a time when gun ownership is at an all-time high. Shows that the gun ban lobby has been wrong, the Citizens Committee for the Right to Keep and Bear Arms said today. The CDC's report for 2010 that removes homicide from the top 15 leading causes of death in this country coincides with a period of record high gun ownership. Well, as I say, better to have it and not need it than to need it and not have it. And I'll tell you, there's nothing that'll thwart an assault, a robbery, or a homicide quite like the possibility that you may be the victim, you being the perpetrator. The Italian cruise ship, that situation is getting worse and worse, or the cruise ship that's trying to capsize off the Italian coast. As a matter of fact, James Childs will speak with us about that. And several other things, asteroids, all sorts of things that we can't really deal with personally, but perhaps our collective consciousness will chill them out just a little bit. So let us just say all hands, man your receptor stations, rig mothership for suborbital sustained inverted flight as we turn the contents upside down. This is Charlie 2, Charlie Alpha Mike. That's Flyboy Talk for Coast to Coast AM. The Phobos Grunt is probe launched by Russian space agency Roscosmos due to land on Phobos, one of the moons in Mars, order to collect soil samples, test atmosphere, possibly discover some weaponizable bacteria to bring back to Mother Earth, search for signs of life. Carrying small capsule of microorganisms intended to test how well they cope with long-distance space travel. However, it might be good that the luck didn't hold out, because what if they morphed into something weird? Mr. Childs, are you there? What's the matter with this thing? Why is it coming back in this unplanned and sort of unstable fashion?
Hi, John.
How are you?
I'm doing fine. Yeah, I'd love to be up there and peek in on it before it burns up.
Well, I'll tell you what, from some of the adventures I've been reading about that you've had, I can just imagine you would like to be up there.
But not too long, because it's going to have a hot ride down. Like I say, some estimates tomorrow afternoon, Eastern time. But it's definitely coming down about 10 kilometers a day, so there is really no question that its time is up. And why this happened is there's some speculation on it. Scientists have some theories, and conspiracy theorists have others. I believe it was probably due to tumbling, where it couldn't recharge its batteries, but certainly it had some really poor communication strategies up there.
So it's not Israel.
Well, unless Israel is an interesting space station because it moves its spacecraft opposite everybody else. It launches to the west rather than to the east, so it makes it kind of an interesting trajectory. But the Phobos Grunt, they tried to fix it in November, couldn't do it, couldn't even hardly talk with it. They don't have the, are you familiar with the PDRS, the U.S. network of satellite communications?
Only vaguely.
It's a network of that allows us to talk to satellites and the space station nearly all the time. Until we had that, we had very poor communication, kind of like the Russians have now. So they were relying on actual amateurs to tell them what the satellite was doing.
Now, is this network for purposes of tasking them and then retasking them? Is that what you mean by communicating with them?
Yeah, it's kind of our, imagine, a telephone system for satellites. That's what TETRS is.
Okay.
Tracking and data relay satellites. That's how we talk to the International Space Station. Because otherwise, we wouldn't be able to point our antennas at it from the ground very often. So Russians don't have that, and that was one of the problems they faced in trying to figure out what the heck was wrong. They were communication challenged.
You've been on the show many times, and this is the first opportunity that you and I have had to speak, so we're doing it between ourselves and also with several million of our closest friends, as I like to say. But,
and I'm happy to do it. I hope for more conversations, too.
Well, me too. Now, is it just an oversimplification to say you study things that you're sort of a failure analyst of systems and of various systems from space to elevators? Is that close?
That's from way down deep to way up high. But I do like to get the message in of real-life heroes, of people that saw into the machine, saw the trouble brewing, and acted in time. So I tried to get the History Channel to have an extra show in my series about that, about the heroes. But instead, it's the stuff that blows up or burns up, the things that make the video. So I go on and do that myself on talks like this or in lectures about who are the heroes, who do we look to, who will pull us out of the fire, who do we lead, which leaders do we follow? That's what I'm particularly interested in.
What are the top 2 or 3 or 4 or 5 or how many you got? What are the things that are really getting your attention these days?
Well, these days, one is Lessons from the Titanic, by golly, 100 years ago. Helping out on a History Channel show on that. It'll be out in April. And so that's why I was interested in the Costa Concordia, because of its evacuation lessons. So that's a subject that's near and dear to my heart, evacuation, people under stress. How do they perform when things are so confusing? Have you ever been in a fire evacuation, John, anything like that, where you had to get out in a hurry?
No, actually, I have not. I mean, I've had to get out of there in a hurry for other reasons, but not because the building was on fire.
It's well, that's a good thing, because sometimes people don't make it out. I call that the last great adventure on Earth, something you can't buy yourself into when the machines are going crazy, sort of like 3 Mile Island. They call it an alarm storm. Have you heard that term before?
Once or twice, yes, I have.
An alarm storm is when the whole panel lights up. Flight 447, that had an alarm storm over the Atlantic, and it's really hard to keep your head in a situation like that.
When the panel's telling you that everything is going wrong.
Yes.
Are we under control? Stand by, please. We are experiencing a temporary communications malfunction, and when Mr. Childs comes back, we will study it. In the meantime, as far as this cruise ship is concerned, the captain has been arrested. So I'm wondering if it's another Exxon Valdez situation. How are we doing, David? We have lost the man. Oh, this is not good. Well, so much for communicating with the satellite. I think we're getting a first-hand dose of exactly what happened to Grunt Phobos. There is no communication now. Satellite will tumble out of control and head toward Earth. Run for huts. Landing site is not predictable at this point. One of the things, I'll just tell you about this. Space. Oh, is he back?
I'm back.
He's back. Okay, excellent. I was just about to go into the casting a high-tech net for space trash, but let's go back to the alarm storm.
It's kind of a modern problem. Didn't have it back in the steam engine days. It's where, and surgeons, I was giving a talk to Mayo Clinic, and surgeons said they have them too. So many alarms, and people put them in there, I guess, because the lawyers want them to, the manufacturers. And it doesn't take much at all for those to go off, and then they tend to set off other alarms. And it's really hard to know how it started and how to stop it. And it can be very, very off-putting, if other things if particularly the situation is unclear, like on Flight 447. As far as the Costa Concordia, we don't know what was going on the bridge. All we know is the captain said, by golly, there was a reef there that I never saw before, and others say, well, you were in the wrong area. Maybe you shouldn't even been looking for that reef.
Oh, boy.
You were way off course. So probably not an alarm storm in that case, but I speculate maybe a power failure on the ship. That's possible.
So once you have the alarm storm, is it then tricky to find out, well, where did this start? In other words, if every red light is on the panel and you didn't notice the sequence by which they came on, is that the problem now? You're just dealing with everything at once and you can't even go back to...
That's right. That's one problem is where did it start? Well, depending on which field you're in, for example, if you're an airline pilot, the rule is fly the plane. Do not allow yourself to get distracted, because that's happened a great many times in a lot of airline crashes where everybody on the flight deck starts worrying about a light bulb or some little glitch rather than thinking, where is this plane? How high is it? Is it level? Where is it going? And it's most likely to happen at night. That's where these problems usually happen. So someone is supposed to watch the plane and not get excited. And there are times the instruments go bad on you, but you normally have some frame of reference, and you must keep your eye on that frame of reference and not be distracted. It's at least one person on the flight deck needs to keep their head.
Let me ask you something. When you remember those two 747s that ran into each other in the Canary Islands some years ago?
Tenerife, yes.
Yeah. How does something like that happen? Is that one of those things that the odds just compel to happen? Obviously, it's a cascading series of unfortunate events.
Well, let me speak generally on the subject is called runway incursions, and those can happen many ways. Again, most likely to happen at night, but not necessarily. On the ground, runways and taxiways are kind of confusing, particularly for a pilot who hasn't been to an airport before. And you can have the ground controllers sending them in the wrong directions or not telling them to hold when they should. It's a compounding, just like you say, a compounding of little things. Pilots take off on the wrong runway, closed runway. How could they possibly do that? Well, it's late, they're tired. They don't notice the cues that they're on the wrong runway. So they assume too much. That's the problem. They're not, the brains aren't turning, they're just going through routine.
When I took my check ride with the FAA designated examiner, he was and still is. I don't know, maybe within the last year or two he's retired, but he was the oldest living designated examiner on the North American continent. He flew Lockheed Hudsons in World War II for the Canadian Air Force because the Army Air Force didn't want him. It was more of a country club in those days.
Wow.
And he asked the question, who do you think makes more mistakes, the controllers or the pilots? And I said, sounds like I should say pilots, but I don't think so. I'm going to guess controllers. He said, that's exactly right. He goes, you're on your own, and you need to verify and check because they're human beings and they make mistakes.
Yes.
And so I suppose that was the situation with this.
I remember my instructor, pilot, he said, when I made a mistake, you have to acknowledge that you've messed it up, that you've boogered it. And once I admitted that, then we could go on with the test. But he said you have to acknowledge when you've made a mistake. Absolutely,
and communicate it. You must confess. And just, if you're in trouble, you just have to tell ATC, I got a problem here. I need vectors. I need vectors, directions. Just tell me what to do. Which makes me wonder what happened with young John Kennedy. He was a new pilot, but he wasn't an incompetent pilot. Do you have any theory on what actually happened to him? Because that was really Seems to me like it set the autopilot and request vectors.
And what was a ground fog situation? Wasn't it out at sea, kind of a loss of horizon?
Yes.
But it was daytime, as I recall. And you wonder how could anybody lose their way in the daytime? But it's possible to not have a very good ground reference and maybe just not be paying attention. That's the only theory I have. Not realizing that the situation you're in is it's not transparently dangerous, but it really is dangerous. So that's that edge of the seat. I've talked with a bush pilot up in Alaska, and he talked about when he landed on a mountain, he would get his rear end up off the seat and just kind of get the circulation going down there because he said he needed that for his part of his instruments was to know if the plane was getting light in the air. So he used every sense that he had because he was really on his own landing on the Arctic mountains. So he was under no illusions of safety, and I think that's maybe one problem with the modern world is that it seems fully under control. But I can tell you so many cases, and I'm sure you've heard of many yourself, where it was not safe at all. People just thought it was. Well, here's one example from the thing I'm watching with the Costa Concordia is their escape modeling. Are you familiar with software evacuation models?
Yes.
Yeah, push a button and it says how people will behave.
Right.
And that's, they used to test airliners by actually hiring people to shove their way out of a darkened airliner. And sometimes people broke their arms, and that's not favored practice anymore, but it was realistic. Now we use software models. And I don't know how much I trust them, but I'm curious because they use them in the cruise industry now, software models for evacuation. So I'm just curious, what did it say people would do when the ship was listing up to 80 degrees? How are they going to get out of there?
I don't know. I wonder sometimes how intelligent it really is to categorize behavior and then assume that your profile is accurate. I mean, there is that human.
It assumes you're like a molecule of water. They actually think of pipes, and in some cases it may be just fine. But only within a certain boundary. And people just one thing it should be obvious to any modeler. I don't know if they include this, that people stop and look for their families. They did that in the World Trade Center. People could have evacuated. No, they wanted to talk to their families, want to communicate with them. Even though their families weren't in the building, you need that reassurance to find your group. And that slows evacuation, but also that's just the way people are. You can't talk them out of it in a high-stress situation. So modelers need to allow for that. You have to. It's called sense-making. There's a term called sense-making where you, under high stress, you try to come up with a theory of a world that's really upside down. And hopefully that's a correct sense-making. Sometimes it's not. But that's why I put my book out there. People are have one more tool to help them make sense of strange events.
Tell us about the book a little bit.
Well, it came out in 2001, Inviting Disaster, still in print. I give talks on the subject and enjoy going around to different fields, engineers, surgeons, technicians, mechanics, and hearing their stories, their interpretation. Boilermakers. I had a real interesting talk with Boilermakers recently about red flags, things that alert them that a machine is in a dangerous state or somebody's not taking care of a boiler. So that subject of red flags got my attention. And may do more with that in the future. The red flag. So it's a book is still out there, and then I did a book in 2007 on helicopters called The God Machine. The God Machine. So I am watching the stories from the Costa Concordia about their use of helicopters to evacuate a few dozen people on the ship. So that subject of evacuation comes up again and rescue by helicopter. What are the reports on loss of life at this point? At this point, 3 is the number of souls lost I've seen, and there's 40 unaccounted for. But given the confusion, if you've seen the photos, that's almost on the rocks. It's very close to the island, and so people were picked up by boat, by helicopter. They swam, and in those situations, it's pretty hard to actually count the heads. So I'm surprised there are only 40 unaccounted for.
All right. When we come back, let's talk about maybe you have some experience with the 1965, back when dinosaurs roamed the earth, that New York City blackout. I wonder what the potential is for it now with these magnetic storms and so forth, and anything else that you'd like to talk about. I'm always ready to study something that's just about to bite us. This is Coast to Coast AM. We shall return. Well, how about some more Greek? We're going to come back with James Childs here in just a moment and take a couple of your calls if you would like. And you know the numbers, so dial them. This is Coast to Coast AM. We shall return in a moment. James Childs, why don't we talk about the Titanic here for a minute?
Hi, John. What do you want to launch into that, or do you want to talk a little bit about solar flares? And
let's do the solar flare thing first, because certainly you must be looking at. Let me ask you a question, because I don't know the answer to this, and somebody famous said it's better to just keep quiet and be thought a fool than open your mouth and remove all doubt, right?
Yeah, Twain.
Do any of your studies involve the geopolitical ramifications of system failures?
They do. It's at the
Excellent.
core of my concern.
Excellent.
Which is, do we really take this grid for granted?
Yes.
I see it as we're sort of living at the top of a tower that is not quite as firm as it feels on an ordinary day. And we see when there are shocks, things like the Kobe earthquake that disrupts the supply chain, or floods in Thailand, that we're much more interconnected than we used to be. And it's just it's a whole new world with many people dependent on artificial fertilizer. We certainly couldn't live off land like we used to. There's too many people to do that. So I guess that my message to readers is, don't take this for granted. We all have to play a part in keeping this ship afloat, as it were. And sometimes the humble people are the eyes that save the rest of us. Repairmen see things, report it, and the experts say, "Oh my gosh, I'm glad you saw that." So I'm hoping to encourage people, and I'm a cheerleader. Know your world, this strange new world that we live in. I find it fascinating. It's kind of scary too.
It's a little bit scary. Do you put stock into this magnetic pole shift, grid collapse, solar flares causing a widespread chaos to coincide with the end of the Mayan calendar, or any of that, or are you strictly pragmatic about it?
I'm not a Mayan guy, but I do think the subject of coronal mass ejections, along with pulse weapons, is something that I don't think it would necessarily bring down the whole grid, but it could certainly cause some major disruptions. We've been in a fortunate time ever since the 1970s, where we had fairly low solar mass ejections, but that's an aberration. There was a giant one, I want to say in the 1850s, just a humongous coronal mass ejection. So that kind of thing would cause major problems. To oversimplify greatly, the grid acts like an antenna with this induced current. Can certainly blow out a lot of things. And to pick up on your question, this whole subject of SCADA gear, which is the supervisory control and data acquisition, that's made the grid somewhat more vulnerable than it used to be. It's more efficient, but it's more vulnerable. I mean, you have power plants that don't even have an engineer at them anymore. They're run by remote, and that kind of thing could be worsened by a coronal mass ejection. So I wouldn't say I'm an alarmist or scaremonger, but just because we've had it good in the past doesn't mean we'll have it good in the future.
Well, the odds compel it. The odds would seem to compel some sort of a noticeable, something worth writing in the history books. But I'll tell you what, I've never heard anybody say it exactly like you said it. So the power generating apparatus actually acts as an antenna and winds up being overloaded by
grid,
these.
The wire, the high voltage wires, and I've been up and close and personal with a 250,000 volt line on a helicopter. We actually bonded to that line. So when that New Zealand balloon went down the other day, it made me reflect, why exactly did that thing explode, where 11 people were killed. But we didn't have any accidents, fortunately, because we were in a helicopter, a bunch of really expert guys who needed to work on the power line. And it was live, of course. It was an energized line. We all wore conductive suits. And anyway, if you know what you're doing, then the system can be pretty safe. but you really have to have an expert by your side.
As far as our power generation is concerned in this country, have you taken a look at the nuclear facilities?
Yes, and some of them are run better than others, I must say. I know New Yorkers would be happy if Indian Point packed up and moved away, not necessarily because I think it's unsafely run, but it's pretty close to New York City. And I think the lesson of Fukushima Daiichi was, people who had nothing at all to do, nothing to gain from those nuclear reactors. I mean, they're thrown out of their house and home. And, I saw the article in National Geographic about people living in boxes in the floors of gymnasiums. That doesn't seem very fair to be run off from their property like that.
Based on the information that you have, and you're liable to hear anything out there, is there any reason to think that Tokyo is at risk and will eventually have to be? I heard this 2 weeks ago that maybe more, that Tokyo will eventually have to be evacuated to some degree. Are you hearing any of that?
Well, I was there about a year and a half ago with my boys, and so I was looking around as we toured. What a fabulous city! Just really enjoyed it to pieces. I loved it. It's not very high off the ocean, and I'd say that's my main concern is were there another big timber like the Sendai, but closer to Tokyo, it would take a giant hit. Now, there are some tidal barriers, but they're not meant to take a tsunami. So, I don't know. I guess you could say they're living on that edge of the volcano, as it were. So now we all, L.A., people put up with risk, feel that it won't happen while I'm here. We rationalize it, have to go on. But yeah, it would be on my mind if I lived in Tokyo, yes. Not so much an earthquake directly, but the tsunami.
Well, supposedly there have been 14,000 extra deaths since that Fukushima problem occurred, and mostly children ages 1 and under. So the radiation seems to be migrating slowly this way, but not enough to cause a general alarm.
It's quite a distance, and certainly there was that alarm about the water supply. Recall that. And that, I believe, was Tokyo's northern reservoirs. There were some radiation hits that caused a good deal of alarm in the city. So it's just its distance doesn't necessarily make it safe. But I'd be happy to go back to Tokyo anytime. I don't feel it's unsafe at all. I think its risks are more from other events rather than from because the plume from Fukushima Daiichi mostly went to the northwest rather than to the southwest, which would be where Tokyo is.
I wonder what's become of the 20 million tons of debris that was floating toward our west coast.
Oh, the great blob. I've heard next roughly 18 months, and it'll start arriving. Quite a bit of it is sunk. But gosh, how odd it would be in Long Beach to see a house come in your direction.
Oh.
There probably are, large structures that heading towards the west coast. I think they're already about at midway, those pieces.
Now that stuff should be relatively decontaminated over that period of time after being washed continuously with salt water, wouldn't you think?
Yes, soaked and dispersed.
So it's not like some green glowing blob is going to show up,
No, it would be
at the beach.
It would be pretty desanitized, but still has a lot of threat, mainly to marine mammals, birds, and fish. That would be my main concern. And tremendous amount of debris when it finally lands somewhere. Yeah, 20 million tons. It may have been more than that. Just stunning images of that mucky wave going out to sea with all those houses and cars in it. What a pile of junk.
Unbelievable. Say, what about space junk? Should we go down to the local pawn shop and see if we can find ourselves some Kevlar helmets to wear? Or
well, it's there's not that much of it up there. I did a rough calculation one time when I was doing an article for Smithsonian, and it's like one piece in thousands of cubic miles. Unfortunately, it's moving very fast. But I found the subject very interesting. I didn't find much hope in going up there and taking it down because it is so dispersed and such a high velocity. But there might be lasers or some kind of energetic. Of course, that'd also be a weapon. There might be some beam that could deorbit them. That's quite possible. But I can't imagine an actual spacecraft zipping around and picking them up like a garbage truck. I don't think that's at all practical. But it is a real hazard. That's the biggest single hazard to the International Space Station is debris. Statistically, that's the hazard. I saw a hypervelocity gun fired at White Sands, the test range there, to check out armor for the International Space Station. About 12 years ago, fires objects at 7 miles a second.
Was that all?
Now they test the Whipple shields. It's called a Whipple shield. That's what helps keep the astronauts safe up there. But not just the big pieces, just the little pieces.
Is that like the latest evolution of the electric, the thing they used to call the rail gun?
They use it's called a hydrogen gas gun. It's a powder charge, and then it's super boosted by a hydrogen fuel. They did not have a rail gun there, but I think in the future, by golly, they'd use a rail gun. They said that if they didn't fire it into a chamber and fired it towards the hills, you would see this spectacular bolt of light as the object, about like a .50 caliber, about that diameter, burned up in the atmosphere. They said it would really make quite a show. But they didn't do that. They were just testing armor. But it was a fun place to be.
Indeed.
So it didn't make me horribly alarmed, but I think astronauts might be more concerned about eye damage and other long-term health issues associated with being in space. But there's no shortage of volunteers. They love to be up there, and they love to go on to Mars. So I guess you could say they know the risk and they accept that.
Do you have much insight into the United States Air Force Space Command and whether or not there's more going on up there than we know?
Well, I did visit the perimeter acquisition radar in North Dakota, which is one of their prime eyes in the sky. That's on the plains of North Dakota on the eastern side. So that's the big radar they use for looking at objects up in space. It's a phased array radar, if you know what that is.
Yes.
And they joked when I was there about spotting aliens, but they were just joking. They said they hadn't seen anything that they would like to tell me about. There's an interesting device along the southern tier of states, United States. It's called the fence. Have you heard of that?
I have not.
It's basically an electromagnetic field that's been running for years. It's sort of like imagine a sheet of energy that runs from roughly San Diego to Georgia, and it goes up in space. And so it beeps, basically causes a beep every time an object passes through. So it's not like radar. It's more like an electromagnetic field that things beep when they go through. They use that for statistical studies of space debris. So I guess you could say we have a glimmering of what's up there. But, when you read these estimates of softball-sized debris, nobody really knows. That's just a radar reflection. They say it's softball-sized. That's just a theoretical thing. Nobody has looked at that object in detail. There are telescopes that can catch the streaks, but they're really too small to see from hundreds of miles away.
What is your expertise in research indicate to you might be the ramifications of projects like, Project HARP and this
the Russians said you destroyed our probe, you darn Amerikanskis. At least one Russian said that.
Really?
I don't see that as any kind of an explanation for what went wrong with Phobos Grunt.
Do you see it as any kind of a threat to the environment eventually with these various fields they're laying up there and all these billions of watts of electromagnetic radiation being focused in a beam and shooting it out all over the place?
And they warned me that at the perimeter acquisition radar up in North Dakota. They said you certainly wouldn't want to stand in front of this thing because it's about 30 megawatts. It's similar to being, you'd be standing in a microwave, an open door of a microwave. But if it fades away over the distance of miles. You just wouldn't want to fly in front of it. So I guess my answer would be it has a near-term acute risk to somebody right in the beam, but I don't, and some might say a big waste of energy. But on the other hand, I don't see any threat. I didn't feel a threat anyway when I was there.
Well, what's the biggest object on your scope at present, as far as a system?
I would say it's automation. It's the dangers of automation. It's complacency of, we talked a little earlier about the alarm storm, but it's more of feeling that the machine will do it, and just year by year our ability to control the machine lapses. So when finally the autopilot hands it over to us and says, "I'm done. This thing's full of ice. It's yours." That's about the worst possible time to take over from an autopilot, and that's happened more than a few times. Pitot tubes, now they don't just cause problems with the airspeed. It actually can cause computer problems. That happened with the B-2 crash several years ago. The computer got bad readings from what acts as a pitot tube in the B-2 bomber, and basically took over from the pilots and caused it to stall, and they had to punch out. So it used to be a pitot would just tell you the wrong airspeed, but now it actually helps the computer make serious life-threatening mistakes. So,
perfect.
I guess you could say automation is a concern. We have to live with it. I just hope people aren't complacent.
What do you see about this? This unique identification number that India has decided to implement over its entire 1.2 billion person population. How do you see that? Have you given any thought or had an opportunity to get into the ramifications of a system like that once it's fully implemented and it's up and running? What might happen if there's a system failure in that regard? Well,
I have not looked at that, John. That's interesting. But can't you say that a cellular phone is sort of a unique number? That I wrote an article on telephones, and I said, one day we'll have a phone number that we have all our life, and I didn't realize it'd be a cell phone number.
It's liable to be your Social Security number.
Well, and they're awfully similar. If somebody knows your cell phone, they can find out an awfully lot. They find out more than they can from your Social Security. They can essentially track where your phone is and know where you are. So I think we might have some of the same concerns here. I'm not sure if India has a lock on that kind of loss of privacy leading to maybe loss of independence. That just happens day by day.
Well, this has been a lot of fun in a quick hour. We're just about out of time here, but tell us quickly, where can we find your books?
They're still in print. Amazon would be a good place. And I encourage people to stay in touch through my blog, DisasterWise, at the Blogspot location. And I give talks. You can always reach me through the Blogspot. That's probably the best way, or the God Machine website. I maintain that website, the God Machine. So if you love helicopters, then check out the God Machine.
I love helicopters, but I thought maybe I'd save something for later because, I don't know, having that between the two controls, I don't know. I'm just afraid that I might have a system interruption. Thank you very much for being with us tonight. And come back again soon.
Good.
This is Coast to Coast AM. For the next 3 hours, we will be joined by a learned and rational man, Dr. Lawrence M. Krauss. He was born in New York, and he has been affiliated with all kinds of absolutely amazing institutions, the Harvard Society of Fellows, Yale University. He was named the Ambrose Swayze Professor of Physics, Professor of Astronomy, Chairman of the Physics Department at Case Western Reserve University from 93 to 05. In 2006, he led the initiative for the no-confidence vote against the Case Western Reserve University's President Edward Hundert and Provost Anderson, which was approved. 2008, he joined the faculty at Arizona State University as a foundation professor in the School of Earth and Space Exploration and the Department of Physics in the College of Liberal Arts and Sciences. Good grief, talk about some bona fides. Well, if we define science as a branch of knowledge or study dealing with a body of facts or truths systematically arranged and showing the operation of general laws, or the state of knowing, knowledge as distinguished from ignorance or misunderstanding, how can this be in conflict with the notion of God? We shall see when we come back with Dr. Lawrence Krauss on Coast to Coast AM. Dr. Krause, welcome to the mothership. Please come up on the bridge and speak with us. How are you tonight?
I'm fine. How are you doing?
Oh, just very well, thank you. You know, you in your book, your new book, A Universe from Nothing. Why is there something rather than nothing? You have a quote or two from Richard Feynman in there, and one of my favorite ones of his is "Science is the belief in the ignorance of experts." But that's what we just keep plugging along, trying to accumulate knowledge.
Mm-hmm.
So, if you don't mind, just state for the audience your thesis of the incompatibility between the concept of God and the pursuit of scientific knowledge.
Well, it's not so much an incompatibility as the fact that what's remarkable, and one of the reasons I wrote the book is to celebrate the knowledge that we've gained over the last 40 years. And what's remarkable about it is we now can see a plausible way in which a universe could come from absolutely nothing without any creator. And in fact, it's not only plausible, but if you measure the aspects of our universe that we can measure, it's completely consistent with that. So we may never, we don't have the pretension to say we might absolutely have the answer, or it must be this way, or there is no creator. Those are not true statements necessarily. But what we can say is it's plausible. It's kind of like Darwin did with the origin and evolution of life on Earth. So you see all this different life that looks like it's designed for its environment, and we now understand how plausible physical mechanism, natural selection, and random mutation could and did produce all of the observable life on Earth. And we don't quite know the origin of life on Earth yet, but we suspect we'll be able to understand how chemistry turned into biology. And what we now understand from particle physics and cosmology by looking at the whole universe and making some astounding discoveries, which themselves are worth celebrating, that in fact a route could be taken to understand how plausibly nothing can turn into something. And you can answer that age-old question from religion and theology. And in fact, that sentence, why is there something rather than nothing, is not a philosophical statement. It's a scientific one, because both something and nothing are scientific terms. And in fact, our understanding of both something and nothing have evolved so dramatically in the last 50 years that you need to understand science if you want to even address those questions. So what we can say is, as my colleague Steve Weinberg would say, science doesn't make it impossible to believe in God, but it makes it possible to not believe in God.
I understand that. Now, am I correct that you were on the show last time? It's not a show; it's a program. Yeah, I like that better, or a program, as they said in the Stone Age.
Yeah.
You haven't been on the program since '07. Is that true?
I think it could be that long. Yes, I can't. Surprising to me, it's been that long a delay since the last time I was on.
Well, tell us something about you, Doctor. What led you into? You have clearly devoted your life to this. You have bona fides that are absolutely staggering, and I'm not giving you the kissing of rump ceremony here.
It's fine to do that too, by the way. Go on.
Well, nobody minds it really, but what led you into this work? I mean, what turned you on and went, I'm going this way?
Well, there are a few things. First, my mother wanted me to be a doctor when I was younger, and then
of course
convinced me that doctors were scientists. And by the time I learned doctors were scientists, I was hooked on science. But mostly, actually, books by scientists like George Gamow and Albert Einstein, and Sir James Jeans, and those books when I was younger really turned me on. And in fact by Richard Feynman too. And it was, in fact, I wrote a book about Feynman a year ago, and I pointed out that it was actually his book that really made me decide to be a physicist. So it's one of the reasons why I write books. I take time out of my research to write popular books, is the hope of returning the favor and turning some young people on to science now. And really nothing gives me more satisfaction than when it happens, and it periodically does happen, because I've been writing books for maybe 15 or 20 years, that some person will come up to me. Someone just did at a book signing last night and said, I've gone back to school because of reading your books. And I think that's just, I feel like I'm returning the favor.
I see a lot of contradiction in some people's understanding of what intelligent design is. Now, I'm looking at, what's become like the handbook for, let's look at Wikipedia, see what it says. Intelligent design, would you agree it's the proposition that certain features, I'm quoting here, certain features of the universe and of living things are best explained by an intelligent cause, not an undirected process such as natural selection.
Yes. I think that's that's a reasonable definition. I think the biggest definition of intelligent design in this country is against evolution. It encompasses lots of people, from young earthers all the way to people who think that somehow cells are too complicated to have evolved. But it's the claim, which is completely unsubstantiated, I should say, that A, that there's evidence for intelligent design, and B, that it's impossible for natural processes to produce what we see. Both those things are not only wrong, but because they've been tested to be wrong. But for the most part, they're actually not falsifiable. Those notions. Science is the process of making predictions based on observations of things about the future that you haven't measured. And if they're wrong, you throw out your ideas. And it's a simple process. Though at least in principle it's simple. In practice, it's difficult because you have to try and prove yourself wrong as much as you could try and prove yourself right. Right, as Feynman used to argue, and the simple fact is that there is no evidence for intelligent design in life, and now as far as we can see, in the universe. And I view it as a remarkable result, and also an inspiring one. Some people think it's depressing that maybe there might not be purpose to the universe, and I say, well, we are so fortunate to be living at this random time, 13.7 billion years after the Big Bang, and that we should take advantage of our brief moment in the sun, that we have evolved a consciousness to be able to learn about the universe and appreciate it, is truly remarkable. And if the only meaning we have in our lives is the meaning we make for our lives, well, it could be a lot worse. We should make sure our lives are meaningful.
You're skilled at not only lecturing but also dealing with students. From the bright ones to the, not as bright ones. So let's have some fun here with this tonight, because I really enjoy talking with people who are so steeped in what they do that they're expert at it. They're as close to a real expert as you can get. So let's start with this. Would you agree that the term atheist is a bit strong? And just just this far into our conversation, you don't strike me as a God denier. You're just saying, look, let's take that out of the equation so we can look at this objectively. Am I close here? I mean, I don't.
Yeah, absolutely. That's the point. I mean, I think we just examine to see what we can understand based on the natural world, and if we can explain what we can see. I think it's presumptuous to say we can say there's absolutely no God. I think what we can say is there's no evidence. There's no physical evidence in any form that I know of that suggests there might be a God, but that's different than saying there is no God. I guess I would put myself more in the camp of my late friend Christopher Hitchens, who, while he's often called an atheist, called himself an anti-theist. Namely, I can't say that there's no God. I can say I'd rather live in a universe without one.
Well, it strikes me that if I were to assert that God does not require a religion, but every religion requires either a God or a statement of an absence of one. Am I close?
Yeah, I think that's right. I think every religion requires us to invent some kind of God, and they're not. And the point is, and the fascinating thing is that most of the religions are inconsistent with each other. So, as we often like to say, most people, even who are deeply religious, are atheists about everyone else's religion, and you just have to take away one more religion to be an atheist about all of them.
Well, is science its own religion?
No, I don't think so. I think the point is that the wonderful thing about science is that faith is shakeable. I may have faith that the universe behaves a certain way, but I'm not. First of all, I'm not convinced I'm right. I think religion tends to say, well, we know the answer before we ask the questions. We know what's right before we even ask questions about nature. Science basically says, well, look, let's try and make some assumptions about what's right. Ask nature what it's like. And then the great thing, to me, the greatest thing about science is you can have a deeply held belief that you think is absolutely right at the core of your being. But the minute the universe tells you otherwise, you throw it out like yesterday's newspaper. And it gives you an open mind in a way that I think is good for everyone. Science ultimately has shakeable faith. As I like to say, as a theoretical physicist, the two most exciting states to be in are either wrong or confused.
This may be a little bit early in our conversation to spring this one on you, but last weekend I spoke with a physicist named Dr. George Hart, and I asked him, do you see any way that information, however it's obtained, might possibly be a living thing? Once it becomes, if you go with the Neville Goddard principle, you know, that fellow from the New Thought movement of the 30s, that there is no reality for us outside of consciousness. No consciousness, no reality. Once information makes itself known, whether we seek it or it seeks us and then we recognize it, do you have any idea that it might in fact be some form of living entity?
Information itself?
Yes.
Well, in some sense, you're asking, do we live in a matrix? Is the information that makes up the world somehow got either created or have a life of its own? And I mean, it's certainly possible, but I see no evidence of it. I think information may be a fundamental building block of nature and a very important thing, but I don't see any evidence that is living or guided by any intelligence. I mean, universal information what makes the universe up.
Do you find that science and philosophy, as a scientist, do you have to keep philosophy separate from it? And how do you do that?
Well, that's a good question. I think it's not a matter of keeping philosophy separate from science. You can have a philosophy. It just becomes irrelevant. I mean, one of the reasons science has made so much more progress over the centuries than philosophy is that science continually gets the information of the empirical information about the real world and probes it. Mere reflection of ideas is useful, but it doesn't go anywhere if you are locked in a room and not looking out at nature. If physicists were just sitting with our equations and not actually constantly probing nature, I can guarantee you we'd come up with a picture of the universe which is dramatically different than the real universe. The universe surprises us in ways we could never imagine. The imagination of the universe is far greater than the human imagination, and if we want to make progress, we keep having to ask the universe questions and probe it with our machines, our telescopes, our particle accelerators, and that's a fascinating business that we can be wrong and the universe can surprise us. And so I think the difference between science and philosophy is the fact that we're constantly being willing to change our mind and even sometimes find that our classical logic is incorrect, that the universe actually doesn't, that we have to change what we think of as sensible. Quantum mechanics, for example, is wilder than you could ever imagine. It's wilder than anyone would have imagined. The electrons at fundamental scales do crazy things. They do many things at the same time, which seems just impossible. And it is on a classical level, but that's the way the world works.
It's very interesting. It's almost like you're at your tool bench, your workbench. You have your tools laid out there. It's like, what did I do with that screwdriver? You're looking at it. Your eyes are capable of sensing that the object is there, but you don't see it. So you stop what you're doing, step away from it, go outside, reset, go back in, and there it is. How often does that happen?
Yeah, well, it happens to me whenever I'm working that I don't that I have something there that I know I have, but I can't see it. And but it's what is weird, in fact, is that at a fundamental scale, if it's an electron, until you actually look for it, it could be in many places at once.
Now, that's very interesting. I understand that there are particles now that have been discovered that can actually exist in different places at the same time.
Well, all particles do at some level until you measure them. They literally are in many places at the same time, doing many different things at the same time, and that's the wonder of quantum mechanics.
You know, I find this sort of thing absolutely fascinating. I'm sure no matter what you do, somebody's not going to like it. Have you noticed that?
Yeah.
But I really hope that there aren't very many audience members rolling their eyes going, God, where are these guys going with this? But it's absolutely extraordinary.
Well, I think so too. I think it's the most extraordinary adventure that humans have been involved in, and I think we should celebrate it. It saddens me that some people think that somehow the knowledge that we get about the universe may threaten their faith, and therefore they'd rather not know. It's sad because it's so wonderful. Then why let that knowledge threaten you? If your faith is threatened by knowledge, then you should re-examine your faith.
Well, do you think maybe it's just a fear of disappointment?
Yeah, I think there's some of that. A fear of disappointment, of also a fear that, if your faith comforts you, and I have no problem with that with people. If your faith comforts you, you're hesitant to maybe put it at risk. But as I say, I think you can gain comfort in reality. You don't have to always turn to myths and fairy tales to gain comfort.
That's very interesting. Well, I just got the 2-minute warning, and this is not football. And the question that I have for you next is going to be I can ask this one. It'd be all right. Where does your inspiration come from?
Oh, well, it's hard to know. That is actually a hard question. It comes from sometimes from my colleagues and good ideas from them, and sometimes just from studying the universe and studying the data that my experimental colleagues bring in. I find it, I guess, once again, whenever they bring in data that's surprising or suggests that my ideas are wrong, I get inspired because that means there's more to learn. If we knew everything, it wouldn't be any fun. So I guess it's the constant, and it has happened many times over my life, the constant perplexing data that comes in that causes me to scratch my head.
Very good. Well, I'll tell you what. When we come back, Doc, I've got a question that's been dogging me for years. What is zero? What is nothing? Is the mathematical function of zero and the actual concept of nothing actually something? And if we take the mathematical component away of zero and nothing being different, then where is nothing? What was there before it? And what's in it? As we discuss Dr. Lawrence M. Krauss's book and the concept behind it, A Universe from Nothing, on Coast to Coast AM. Stand by. I urge you to become a Coast Insider. You will have fun with it. You can listen to the shows anytime you want. You have 1,000 of them you can go back and listen to. And it makes the day go by a little bit quicker when you're listening to a wonderful guest like our guest tonight, Dr. Lawrence Krauss. And we're going to get back with him in just a moment on Coast to Coast AM. Well, so why is there something from nothing? I mean, why is there not nothing, but there is not something in what? Well, you know what I mean. No, you don't, because it was very convoluted. Let me ask you something. How big is the contradiction factor in the data that you pull in from your various sources? In other words, as I go through some of the data now, I'm not, I haven't studied word for word and effectively memorized your book. But it seems like there are some contradictions, but in the end, it's okay because they balance each other out and they support your argument.
Well, thank you. I think that I try in the book to prepare, and it's pretty short too, which I think is important for science books so people don't get lost or intimidated. Is to present the historically discoveries over the last century that have systematically changed our picture of the universe, from the discovery of the Big Bang itself to the remarkable discovery that probably one of the most remarkable discoveries in the last 100 years, if not more, that the dominant energy in the universe actually resides in empty space, which is remarkable. If you get space and you get rid of all of the matter and all the radiation, so you got nothing there, the space weighs something. And that kind of energy that you put in empty space is actually gravitationally repulsive, not attractive. High school students learn that gravity sucks. But in fact, it doesn't. It always. And if you put energy in empty space, it can actually blow instead of sucking. So it actually, the universe is dominated by a force, a repulsive gravitational force that's causing the expansion of the universe to speed up, not slow down. And that's what we've measured. In fact, that's what was the subject of this year's Nobel Prize in Physics.
Well, you probably read this in kindergarten, given the amount of education that you've had, and now you propagate. But the Michelson-Morley experiment, where these two fellows decided they would prove that there was an ether wind, and when they felt like their experiment failed, what they'd in fact done is prove that there was no ether wind.
Mm-hmm.
And now it appears that there is some sort of force, like Obi-Wan Kenobi says, that penetrates us, surrounds us, it binds the universe together. And so does that mean that the concept of zero, upon which the whole school of mathematics pretty much depends, is different than the concept of nothing?
Well, potentially. I mean, I'm quite familiar with the Michelson-Morley experiment. I actually had the chair before I moved to Arizona. I had the same chair at Case Western Reserve that Albert Michelson did, so I was quite honored to have that. I think what we now know that that empty space is far more complicated than we thought it was. That there are interesting properties of empty space that we had no idea about before we discovered them. And I think, and so what it means is that the physicist zero is a little bit different than the mathematician zero. That empty space, which has zero total particles in it, so you can measure it and say how many particles are in this region. There's none. Actually, is a boiling, bubbling brew of virtual particles that pop in and out of existence in a time scale so short that you can't measure them. Now that sounds like counting angels on the head of a pin. It doesn't sound like science if you can't measure them. But in fact, while we can't measure their effects directly, we can measure their effects indirectly, and we can actually determine them and predict them. And they produce the best measured predictions in all of nature for the properties of atoms and elementary particles. So we know that those virtual particles are there. If they weren't, we'd get the wrong answers. And that means that empty space is actually far more fascinating than you might have imagined otherwise.
Would you please just amplify virtual particles?
Well, the laws of quantum mechanics. They say it's kind of like it's kind of like the White House. If you can't see it happening, anything goes. And the Heisenberg uncertainty principle tells us that you can only make measurements of nature with a certain uncertainty, certain combinations of measurements. I can't measure exactly where an elementary particle is and exactly what it's doing, where it's going, and at the same time, there's always some uncertainty in that. Similarly, I can't measure the energy of a system exactly if I only measure it for some short time. Well, if I measure a region of the universe for some short time, that means I can't say precisely that it has zero total energy. I can say it has zero plus or minus some uncertainty, and that means, of course, that it's possible that there's some stuff in there that will go away before you can measure it, and there are always quantum fluctuations. And the uncertainty principle tells us that on small scales, nature and space are constantly fluctuating, producing particles, they're going away, producing them, and they're going away. As long as on average they're not there, they don't violate the conservation of energy. I kind of liken the universe to a savvy stockbroker instead of an embezzler. A savvy stockbroker buys stocks with money he doesn't have. He buys stocks on margin, usually his client's money that he doesn't have, buys it on margin when he has less money than can account for all of the stocks, and then hopes the stocks go up and then sells those stocks and end up making money from nothing, literally. And whereas the embezzler does the same thing and it's discovered. Well, the universe is more like the savvy stockbroker. It borrows energy from nothing and returns it on a time scale so short you can't measure it. Now, the really neat thing is when you add gravity into the mix, there's not only positive energy of particles, but also negative energy. And that means you can create particles that have positive energy because of their mass. Einstein told us E equals mc squared. So when I create some particles, they definitely have energy, but their gravitational attraction can produce a negative potential energy. And if the two add up to precisely zero, then you can create particles with impunity, and we do it near black holes. That's what made Stephen Hawking famous. So the amazing thing is, because of gravity, you can start with nothing and then have a quantum fluctuation and produce real particles that are there and persist, and in that way you can actually fill up an empty universe with matter.
That's very interesting.
I think so. I think it's so fascinating, it's worth writing a whole book about.
Well, here's the thing, going back to these virtual particles. When they disappear, where do they disappear to?
Back into emptiness, back into nothingness.
Which is what?
Well, as I say, it's a state where, if you're just a physicist, it's a state where, on average, if you measure it, you can't see any particles.
Okay.
So that and now, in fact, one of the things I do in my book, because I've talked to theologians, and they once again, I reiterate, nothing is not a philosophical concept. It's a theoretical concept. It's a physics concept, and you have to be very careful. And so there's one kind of nothing, which is just empty space. And what I can show is that empty space is unstable, and it will always create something. But when I say that, then some people say, well, that's not really nothing, because the space is there. You have an eternal empty universe is still full of space, and that's not nothing. You need a God to create that space. Well, it turns out when you apply the laws of quantum mechanics to gravity, then even space itself can pop in and out of existence. Whole universes can be created spontaneously where there was no space before. And again, as long as those universes have zero total energy, they can be created with impunity. They can last arbitrarily long times. And in fact, the properties of our universe look just like such a universe. Then people say, well, really, that's not nothing because, okay, you don't have the particles and you don't have the space, but you still have the laws themselves. Who created the laws? And the third remarkable part of all this is that we now think, and we've been driven to, not because of some philosophical predilection, but because of our efforts to try and understand how the universe actually works, that it's quite possible that even the laws themselves rise spontaneously as the universe created. Namely, there could be a multitude of different universes, in each of which there are different laws of physics, and only those in which life could form would we find ourselves. So it's not too surprising to ask yourselves, why is there something rather than nothing? It'd be much more surprising to ask why there were nothing, but then you wouldn't be there to ask the question.
Well, obviously, we carry on with our studies because not everything is known.
Exactly. There's much more that's not known about the universe than is. I'm the first one to say that. But the wonderful thing is there's a lot that we do know, but we carry on the studies not just to confirm what we know. The adventure wouldn't be interesting if there wasn't a matter of learning more, and that's why I say it's being wrong or confused is so exciting if you're a theorist. And the universe is so remarkable that we have to keep probing it, and it keeps on surprising us. Every time we open a new window on the universe, we're surprised.
Does it strike you as odd that with all of the equipment that we have for looking effectively back into time at these stars and these galaxies, that amazing radio telescope that gave us images of galaxies colliding and so forth, this actually happened a long time ago?
Yeah, well, that's what's amazing. When we look out at the universe, we're doing cosmic archaeology, if you wish. We look at galaxies that are 5 billion light years away, and we're looking back in time 5 billion years. The light from those stars that is received by the camera or a telescope that absorbed that light was emitted 5 billion years ago. That means when we look at a beautiful system of clusters of galaxies, many of the stars that we're now seeing in that picture no longer exist. And there may have been civilizations in those galaxies billions of years ago that no longer exist. So we're looking at a snapshot way back in time. It's inspiring every time I look at a Hubble Space Telescope picture and see a system of galaxies 5 billion light years away, which formed. That meant the light left them before the Earth formed and the Sun formed, because our Sun is only 4.55 billion years old.
So time is a thing.
Well, it is a thing that absolutely time is a thing. I learned that when I had to wake up in the middle of the night to do your program.
Okay. All right. Well, so where do we go from here?
Well, we keep on exploring and try and check our ideas and try and learn more. There's still a lot to learn. Where we go is to try and see if there's any way our theories can give us ways to test some of the most speculative ideas at the forefront. But let me just say, one of the things we do know in principle, and this is more like Charles Dickens' Christmas story, because I'm going to tell you the future as it might be rather than the future as it must be. But if the future is dominated by this dark energy that now appears to dominate the universe that we don't really understand anything about, it's the greatest mystery in science. But if that dark energy persists, as we have every reason to believe it will, then the future will be quite different than we once thought. The future is miserable. The long-term future of the universe. Namely, galaxies that we now see are moving away from us, but their motion is increasing. The expansion of the universe is accelerating. Those galaxies are moving faster and faster, and eventually they'll be moving faster away from us faster than the speed of light, which is allowed in general relativity, and the entire universe will disappear before our very eyes. Now, it won't be before our very eyes because you can calculate how long that will take, and it'll take several 100 billion years. But astronomers around some star and what will then be the Milky Way galaxy in the far future will look out, and they'll see the universe we thought we lived in 100 years ago. 100 years ago, it's amazing, less than a human lifetime ago, we thought we lived in a universe that consisted of one galaxy that was static and eternal. We didn't know about the Big Bang. We didn't know about the other 400 billion galaxies in the early universe. In the universe, which really says we're like the early map makers. Our picture of the universe is changing dramatically because we're just beginning to understand it on larger scales. But I find it kind of poetic that in the far future, astronomers will be driven to that wrong picture, and that quaint picture that we had 100 years ago, that our galaxy was all there was, and it was surrounded by an eternal empty space.
You realize that this parallels information that is written in Scripture.
Well, I'm not so sure, but you can tell me how.
Well, I mean, if you go to the Book of Revelation, it describes this very thing where effectively your universe that surrounds you effectively runs away from you. Now, on what time frame we don't know. Because, I personally think the Bible is a very heavily coded book, but I also think that it is a scientific work rather than a strictly philosophical work.
It's fascinating that you say that because it was certainly written by people who were writing at a time when we didn't even know the Earth went around the sun, much less about quantum mechanics. So I find it, I take the attitude more like St. Augustine and several others who said the Bible isn't a scientific document and in fact, or Moses Maimonides, the famous Jewish philosopher, who said, as he said it, the scriptures are absolutely true, and he believed that. But if the evidence of science disagrees with the scriptures, you should re-examine your interpretation of the scriptures. Yeah,
I've heard that one too. Well, you're a human being. I am one. Everyone in the listening audience.
Both are, yes.
Well, yeah, I mean, some people have said other things, but don't you find it interesting that, I'm sure you do, that no matter how far we look into space, no matter how far back into time we look as we look into space, we see no planet that really compares to ours. There are components of it here and there, or maybe this one supported life at one time, but there's not another Earth within range that we can see.
That we can see yet. I think one of the more exciting things is that we've discovered in the past 5 years 2,000 planets, and we're discovering just the other day, this week, it was reported a whole new solar system with planets that were smaller than our planets. We're discovering once again the universe is stranger than we thought, but I fully expect that with the 100 or 200 billion solar systems in our galaxy alone, that we will in fact, probably in our lifetime, discover Earth-like planets orbiting Earth-like distances around their stars, and the fascinating question, of course, will be: is there life of any sort on those objects? Are we alone in the universe?
So you haven't ruled that out, or are you?
Oh no, I haven't ruled it out at all. I think it's quite plausible. Is there intelligent life? Well, that's much less likely, but there could even be intelligent life. I think it's going to be hard to know because unfortunately the galaxy is a big place, and it takes a long time to get signals from such places. And if as I like to say, when I have TV, I rarely find the TV show I'm looking for because there are 200 channels, and by the time I find it, the show's over. In the real universe, there are an infinite number of frequencies to broadcast at, and we have to try and probe all of them. And it's like trying to find a needle in a haystack, but maybe we'll be lucky.
Now, listen, I'm not trying to make you mad here, but I have to ask you this. Mm-hmm. How can there be intelligent life without intelligent design?
Well, I think we've learned that on Earth. We've discovered the remarkable fact that the Earth is teeming with diverse life of all different sorts, none of which was designed. that life has evolved in remarkable ways to produce remarkable creatures. And at least one of those creatures has, for whatever reason, which we don't fully understand, gained a consciousness. Although some people would say my dog has a consciousness, and maybe it does. And we understand how from single-celled molecules, self-replicating molecules that take energy from their environment, that combined with the fact that their DNA can allow mutations and more efficient systems can begin to dominate their ecosystem, and that populations with a variation in their genes will evolve so that the ones that can most effectively use their environment will dominate. We've discovered remarkably that you can produce the beautiful and amazing diversity of life on Earth without guiding the process. And I think that's one of the discoveries that's not worth being afraid of, but worth celebrating. Isn't it amazing that we've discovered that, the bees that can see the colors of flowers to get the nectar to make honey, that can happen that remarkable thing can happen by natural mechanisms. It's like Richard Feynman once said, just understanding how a rainbow works doesn't make it any less beautiful.
Understood and appreciated. And when we come back with Dr. Lawrence Krauss, we're going to discuss what is the definition of design, a real definition of design, which may be more difficult than you might think, when we continue on Coast to Coast AM. An intriguing and stimulating conversation underway with Dr. Lawrence Krauss, and we will continue with it in just a moment. Please just stay where you are. Dr. Krauss, you're at the University of Arizona now, yes?
Arizona State University.
Arizona State. Now, this Arizona State is widely known for exploring advanced subjects. Quantum physics, quantum mechanics, stuff like that.
Yeah, that's one of the reasons I moved there. It's getting more and more widely known. I run an amazing institute called the Origins Project that looks at everything from the origins of the universe to the origins of consciousness.
Now, is that in the actual science department?
It actually spans all the departments of the university. That's what's wonderful about it. We bring together from different fields individuals and focus on fascinating questions and use interdisciplinary techniques to try and address them. So I find it very, very exciting.
Before I go much farther with this, I'm quite a fan of the Three Stooges. And the other day I saw Mo smack Larry and said, "What are you trying to do, make a fool out of the doctor?" Because Shemp was asking, "What's good for a broken neck?" And he smacked him. He goes, "I don't know either." But but here's the thing. When you have people from Arizona State involved in these things, visualization, the power of the hypothalamus, all of that stuff, and then, what about the simple act of observation affecting the outcome of an experiment? It just seems to me that nothing happens. I go back to the comment I made a while ago about we're all humans here. So basically, given the varying levels of intelligence and smartness, which in my view is the practical application of intelligence, it seems to me that nothing happens whatsoever without intent, whether it's a shoot of a plant coming up out of the ground or whether it's a rock being bounced off another caveman's head. That premise combined with, it's been shown, Schrodinger, I believe, is the one who effectively, I don't know if he proved it, but he certainly documented it and observed it, that the simple act of observing an experiment can affect its outcome. Now, how does this tie in with creation, and how does this in some way contradict intelligent design, in your view?
Well, let's see. When there's obvious intent when a caveman throws a rock at another caveman. I don't think there's obvious intent when a rock gets dislodged from the cliff above the caveman because there's a weak link that eventually breaks down and hits the caveman on the head. And now, so even classically, I think there's not always intent for everything that goes on, but in the quantum universe, it is much more fascinating. Now, unlike a lot of people think, and there's a big misunderstanding about quantum mechanics. Quantum mechanics is perhaps the most misunderstood theory in physics by the layperson. Quantum mechanics itself is a completely deterministic theory. It tells you that a system evolves in a well-defined way by